Hello students, welcome to CDS Quest YouTube channel. Let's begin with the class. Median. Median is a line segment joining a vertex of the triangle to the midpoint of the opposite side. That means, now here is the triangle. Suppose this point is A, B and C. The opposite side of this vertex A is this BC line only, opposite side of this vertex A is this BC line only. Now the line segment joining this vertex A onto BC line. This is the line segment joining vertex A onto BC line at D. This point is D. And this AD line is called median. And this median divide this BC line into two equal lengths. That means BD, this length is equals to DC, this length. Okay, BD equal to DC. Median, AD is the median line that divides this opposite side BC line into two equal lengths, that is BD is equals to DC. Okay, okay. Next, now here is the triangle. This is the first median, this is the second median, and this is the third median. Now these three medians meet at this point. These three medians meeting at this point. So this point is called centroid, and it is represented with capital G. Capital G. That statement written here. The point of intersection of three medians is called centroid. Okay. Okay. Now in this triangle, in this another triangle, this is one median, and this point is centroid G. Centroid G. Now this centroid divides the median into 2:1 ratio. 2:1 ratio. This line is the median. This G is the centroid point. This centroid divides this complete median into 2:1 ratio. Okay. Okay. From centroid to the vertex, length is two parts. Okay. From centroid to side length is one part. Okay. Remember this one also. Thus that point is written here. Okay. Centroid divides the median into 2:1 ratio. Important point. Remember this point. Okay. Now this is the important point. Centroid always lies inside the triangle for all type of triangles. That means whether it is a acute angle triangle or right angle triangle or obtuse angle triangle, whatever the type of the triangle, the centroid always lies inside the triangle only. Inside the triangle only. Okay, remember this point, important point. Next, now This is the one median. This is the one median. Dividing this complete triangle into two triangles. This is the one triangle and this is the another triangle. That one median dividing this triangle into two triangles. Two triangles. Now these two triangles have equal area. This triangle area is equals to this triangle area. This both triangle have equal area. Equal area. That is the statement written here. One median divides the triangle into two equal areas. Okay. Okay. Next. Now this is the one median in this triangle. This is the second median. This is the third median. Now these three medians divided this complete triangle into six triangles. This is the first triangle. This is the second triangle. This is the third triangle. Fourth, fifth, and sixth triangle. And these six triangles have equal area. Equal area. This triangle area equal to this triangle area, and all these triangles, small triangles, have equal area. Okay. Okay. Three medians divide the complete triangle into six small triangles of equal area. That is the statement written here. The three medians divide the triangle into six small triangles of equal area. Equal area. Okay. Okay. Next. Length of the median. Suppose this vertex is A, B, and C, and this is the one median, and this point is D, and this is the second median, this point is E, and this is the third median, this point is F. Suppose the length of BC line, the length of BC line is A, and the length of AC line is small b, small b, and length of AB line is small c. Now the length of median AD, AD is the median only, no, first median. Now the length of AD is equals to half into square root of 2b square plus 2c square minus a square, minus a square. This is the AD median length formula. Okay. AD median length is equals to half into square root of 2b square 2c square minus a square. Okay. Okay. Similarly, BE is also second median, no? BE is the second median. Its length is half into square root of 2a square plus 2c square minus b square. This is the BE median length formula. Next, CF is the third median. No? So CF length is equals to half into square root of 2a square plus 2b square minus c square minus c square. These are the three formulas for AD, BE, CF median lengths. Median lengths. Okay, these are the three important formulas you people need to remember. Okay, okay. Next, if two medians are perpendicular, then suppose here is a triangle. This vertex is A, this vertex is A, B and C. And this is the one median and this is the second median. If these two medians are perpendicular to each other, these two medians are making 90-degree angle with each other. Then here suppose this is the meeting point of the three medians. Two medians is called centroid. No, it is represented with G. And these two medians are perpendicular to each other. Then the condition is AB square plus AC square is equals to 5BC square. This is the condition when two medians are perpendicular to each other. Perpendicular to each other. Okay. Okay. When two medians are perpendicular to each other, the condition is AB square plus AC square is equals to 5BC square. 5BC square. Next. Relation between sides and medians of a triangle. Now here is a triangle. Suppose this vertex is A, B and C. And this is the first median meeting BC at D. This is the second median meeting AC at E. This is the third median meeting AB at F. At F. Now the relation between medians and sides is 3 into AB square plus BC square plus CA square is equals to 4 into AD square plus BE square plus CF square. This is the relation between medians and sides of the triangle. This AB, BC, CA, AB, BC, CA. These are the sides of the triangle, and AD, BE, CF. AD, BE, CF. These are the medians of the triangle. So in words, this formula, this relation can be written as, this relation in words can be written as 3 times of sum of squares of squares of sides is equals to 4 times of sum of squares of medians. Okay, this is the relation between sides and medians of a triangle. Next, now here is a triangle. Suppose this is the first median of length m1, and this is the second median of length m2, and this is the third median of length m3. Third median length is m3. Now the area of the triangle is equal to area of the triangle is equals to 4 by 3 into square root of s into s minus m1 into s minus m2 into s minus m3. This is the formula for area of the triangle when median lengths are given, not sides, median lengths are given. This formula is applicable to find area of the triangle. Okay, important formula, remember this one also. And S is equals to m1 plus m2 plus m3 divided by 2. This is the S formula. Okay, m1, m2, m3 are the length of the medians. Okay. Next, now here are the 3 statements. The first statement is, in a triangle, if 2 sides are equal, then 2 medians are equal. This is the one fact. Now here is the triangle. Suppose these 2 sides are equal in this triangle. This side is equals to this side. Then this median is equals to this median. This both medians have equal length. Okay. When 2 sides are equal, then 2 medians also equal. Next, if 3 sides are equal, then 3 medians are equal. This is the second statement. 3 sides are equal, then 3 median lengths also equal. Okay, this is the second statement. And if 3 sides are different, then 3 medians are different length. If 3 sides are of different length, then median lengths also different. Okay, remember these 3 statements. Okay, next, up to now medians and centroid properties are completed. Next one is angle bisector. Angle bisector is a line that divides an angle into two equal angles. Two equal angles. Suppose this is a angle A. Angle A. This is the angle A. Now I am drawing a line that dividing the angle A into two equal angles. This is the line I have drawn such that this A angle divided into two equal angles. This angle is equals to A by 2. This angle also is equals to A by 2. Now this line is called angle bisector. Angle bisector. Angle bisector is a line that divides an angle into two equal angles. This angle equal to this angle. Yes or no? So this line is called angle bisector. Angle bisector. The angle between the interior angle bisector and exterior angle bisector is 90 degrees or perpendicular. That means now this angle we call interior angle and this angle we call exterior angle. Exterior angle. Now the angle bisector of this interior angle we call it as, this is the interior angle, the angle bisector of this interior angle we call it as interior angle bisector, and this is the exterior angle, no? So the angle bisector of this exterior angle, this is the angle bisector of this exterior angle, so it is called exterior angle bisector. Exterior angle bisector. Now the condition is the angle between this interior angle bisector and exterior angle bisector is 90 degrees. Is 90 degrees. The angle between this exterior angle bisector and interior angle bisector is 90 degrees. They both are perpendicular. 90 degrees means both are perpendicular to each other. Perpendicular to each other. Okay, this is the condition. Next, now here is a triangle. Suppose this vertex is A, B and C. This is the one angle bisector. This is the one angle bisector. That means this is angle A by 2. This is also angle A by 2. And this is the another angle bisector. That means this is angle B by 2. This is also angle B by 2. And this is the third angle bisector. Then this is angle C by 2. This is also angle C divided by 2. Angle divided by 2. This is the three angle bisectors in one triangle. In one triangle. Okay. These are the angle bisectors. angle bisectors. Next, now here if you see, a triangle is there, and inside the triangle one circle is present. One circle is there. Inside the triangle one circle is there. So this circle is called as in circle. Inside the triangle one circle is there. That circle is called in circle. And this circle have one center. This circle have one center. This center is called in center. That is represented with capital I. Capital I. And here is the another triangle. Suppose this is the one angle bisector. This is the another angle bisector, and this is the third angle. Sorry, this is the third angle bisector. And these three angle bisectors are meeting at this point. Now this point is called in center. In center. This point also called in center. These both points are same. These both points are same. That is a statement written here. The point of intersection of three angle bisectors of a triangle is called in center, and it is represented with capital I. Capital I. These both points are same. This is the in centers. In centers. If you see here, this is the important point. For all type of triangles, the in center always lies inside the triangle. Suppose it is a acute angle triangle or right angle triangle or obtuse angle triangle. Whatever the type of the triangle, the in center always lies inside the triangle only. Okay. Okay. Remember this point. Now here is a circle. Here is a triangle. Inside the triangle, a circle is there. This circle we call in circle. I said in the previous slide, this circle is called in circle, and it has one center. That center we call in center, and it is represented with capital I. This is in center. Now this length, and this length, and this length, this all line lengths are equal because they all are radius of this circle. Radius of this circle. So it is represented with small r, and this length small r is called in radius. In radius, and it is represented with small r. Small r. Now the formula for in radius. In radius. Small r is equals to delta divided by s. This is the formula for in radius. And delta, where delta is equals to area of the triangle. Area of triangle. And s is equals to semi perimeter of the triangle. of triangle. This is the formula for n radius. Okay. Next, now here this is one angle bisector and this is the another angle bisector, and the meeting point of both angle bisectors we call in center, and it is represented with the capital I. Suppose this opposite angle is theta. This opposite angle is theta. Just wait guys, this is small, this capital I. Suppose this angle is theta, then this angle is 90 plus theta by 2. 90 plus theta by 2. Very important. You have to remember this condition. When two angle bisectors is drawn such that they meet at one point, that point we call in center, and the opposite angle is theta, then the angle made at the in center is 90 plus theta by 2. 90 plus theta by 2. Remember this condition, very important. Okay. Similarly, suppose this is the triangle, and this is one angle bisector, this is the another angle bisector, and this is I in center. Suppose this angle is alpha, then this angle is equals to 90 plus alpha divided by 2. Okay, this is the opposite angle of this angle, so 90 plus alpha by 2 is the answer. Okay, this is the theta is the opposite angle of this now, so this angle is 90 plus theta by 2. Here alpha is the opposite angle of this angle, so 90 plus alpha by 2 is the answer for this angle. Okay. Similarly, if this angle is given, now here is a triangle. Suppose this is one angle bisector and this is the second angle bisector. They both meet at one point, that is in center. Suppose this is beta, then this angle is equal to 90 plus beta by 2. Beta by 2. Okay. Clear with this? Next, now here is a triangle. Suppose this vertex is A, B and C. This AB line is extended up to D. Suppose this AB line extended up to D and AC line extended up to E. Okay. Now this DBC, this angle is exterior angle, no? This DBC, this angle is the exterior angle. Yes or no? Now this is the exterior angle bisector. This line is the exterior angle bisector, and this ECB, this is also exterior angle. Yes or no? Now this line is the exterior angle bisector. This line is the exterior angle bisector. Now they both exterior angle bisectors meeting at one point. This point is called X center. X center. These both lines are exterior angle bisectors. Okay. Okay. Suppose this A vertex, this angle is theta, then this angle is equals to 90 minus theta by 2. 90 minus theta by 2. As I said, when interior angles is there, interior angle bisectors is there, then this angle is equals to 90 plus theta by 2. When exterior angle bisectors is there, then 90 minus theta by 2. Remember this formula. Okay. Don't confuse with interior angle bisectors and exterior angle bisectors. When interior angle bisectors is there, 90 plus theta by 2. When exterior angle bisectors is there, then 90 minus theta by 2 is the formula. Okay. Okay. Next, this vertex is A, B and C. Now this from A to on to BC, an angle bisector is drawn. Suppose this point is D. This is the angle bisector. AD is the angle bisector. This angle is equals to this angle. Okay. Okay. Now the condition is AB divided by BD is equals to AC divided by DC. This is the condition. This is the condition. AB is this line only. No? This line divided by BD, this line is equals to AC, this line only. No? Divided by DC, this line. Okay. This AD line is the interior angle bisector. It is, this line is inside the triangle, no? So that's why it is called interior angle bisector. Okay. Okay. Next, here is the another triangle. Suppose this vertex is A, B and C and C. Now I am extending this BA line. I am extending this BA line, and this angle is the exterior angle. No, exterior angle. This angle is the exterior angle. I am drawing a angle bisector of this exterior angle. This is the exterior angle bisector. Exterior angle bisector. Now I am extending this BC line up to it touches the exterior angle bisector. Extending this BC line until it touches the exterior angle bisector. This point, suppose it is D. Okay. Now the condition is AB divided by BD is equals to AC divided by DC. Okay. This is the condition. This both are same formulas, there is no change. If you see properly, these both formulas are same formulas, there is no change, but the change is in this interior angle bisector and exterior angle bisector. You need to know this, you need to label it properly. When exterior angle bisector, the D point is outside the triangle. When interior angle bisector, the D point is inside the triangle. You need to remember this. Okay, okay, okay. When exterior angle bisector is there, AB, this line, divided by BD, this complete line, is equals to AC, this line is equals to CD or DC up to here. Okay, remember these conditions. Both conditions are very very important, very very important, very very important. This point is A, B, C, and I am extending this BC line up to here. Now this angle is the exterior angle only. No? Now I am drawing a exterior angle bisector. This is the exterior angle. I am drawing the bisector such that it is called exterior angle bisector. Exterior angle bisector. Now this B angle, this is interior angle. No? Now I am drawing an interior angle bisector. This is the bisector of angle B such that it is called interior angle bisector. This line is called interior angle bisector. Interior angle bisector. Now suppose this vertex A, here is the angle, no? This angle is theta. This angle is theta. Then this angle between this exterior and interior angle bisector, this angle is equals to theta divided by 2. Theta divided by 2. Remember this condition. This angle is theta, then this angle is equals to theta by 2. Theta by 2. Remember this condition also. Very, very important. Next. Angle bisector in center properties are completed up to now. Now next is perpendicular bisectors. Perpendicular bisector, also it is called side bisector. Perpendicular bisector is a line that divides the side into two equal parts and forms a right angle triangle with the side. That means here is a line. Suppose here is a line A, B, and I am drawing a line that is perpendicular to this AB line. This is perpendicular to AB line and meeting AB at D. Suppose this is C. This is C. This is C. And this line dividing the AB line into two equal lengths. Now this line is called perpendicular bisector. Perpendicular bisector is a line that is perpendicular to the opposite side and divide this opposite side into two equal lengths. That is AC length equal to CB length. Okay, this line is called perpendicular bisector. Okay, next Now here is a triangle. Here is a triangle, and circumference of this circumference of this triangle, a circle is present. A circle is there now. At the circumference of this circle, at the circumference of this triangle, a circle is present. So this circle is called circumcircle. Circumcircle. Now this circle have one center. Yes or no? Every circle have one center. Now this center, circumcenter, and it is represented with capital C. Capital C. This is capital C. Now here is the another triangle. Suppose this is one side bisector or perpendicular bisector, and this is the second perpendicular bisector, and this is the third perpendicular bisector. Now the meeting point of these three perpendicular bisectors is called circumcenter. This is also capital C. These both centers are same. They both are circumcenters only. Okay. That is the point written here. The point of intersection of three perpendicular bisectors is called circumcenter. The point of intersection of three perpendicular bisectors is called circumcenter. Okay, clear with this? Next, now here is a triangle. Sorry, forget to take the right circle. Okay, no problem. Now here is a triangle. At the circumference of this triangle, a circle is drawn. A circle is drawn at the circumference of this triangle. Now, as I said in the first, before slide, this circle is called circumcircle, and it has one center. This circle have one center, and it is circumcenter, capital C. From the circumcenter to vertex of the triangle, these three lengths are equal, because these three are radius of this circumcircle. Yes or no? So this length is called circumradius. And it is represented with capital R. Suppose this side length of this triangle is small a, and length of this side is small b, and length of this side is small c, then the circumradius R is equals to ABC by 4 delta. This is the formula for circumradius. Very, very important. we need to remember this also. Okay, ABC by 4 delta, where A comma B comma C are the sides of the triangle, and delta is equals to area of triangle, okay, area of triangle. Okay, next, now here is a triangle. Suppose this point is circumcenter C, capital C. Now I am joining this vertex to this circumcenter and this vertex to this circumcenter. Suppose this vertex, this opposite vertex, this opposite angle is theta, then this angle is equals to 2 theta. This angle is equals to 2 theta. Okay, when circumcenter is there, this opposite angle is theta, then this angle is equals to 2 theta. Remember this one. Okay, remember this condition. This is also very, very important. Next, now here is a triangle. These angles are less than 90 degrees, so it is acute angle triangle. Yes or no? This is acute angle triangle. If I draw perpendicular bisectors for these three sides, so this circumcenter, this is circumcenter, this point of intersection of three side perpendicular bisectors is circumcenter. This circumcenter is present inside this triangle only, no? So write this in statements. In acute angle triangle, in acute angle triangle, circumcenter lies inside the triangle, Now here is the right angle triangle. Now this is the one perpendicular bisector and this is the second perpendicular bisector. These two perpendicular bisectors are meeting on the midpoint of the hypotenuse. So write this is, and this meeting point we call circumcenter only, no? So write this in statements. In right angle triangle, circumcenter lies on the midpoint of the hypotenuse. Okay, remember these 2 points. Okay, next, this is the obtuse angle triangle. Now suppose I draw for this line and perpendicular bisector, for this line a perpendicular bisector. So these two perpendicular bisectors are meeting outside this triangle. So this is C, circumcenter. Write down this in statements. In obtuse angle triangle, the circumcenter lies outside the triangle, outside the triangle. Okay, remember these 3 points. Okay, okay. Next, up to now, circumcenter and perpendicular bisector and its properties are completed. Next, altitude. Altitude. Here is the altitude. Altitude. Altitude is a line segment drawn from a vertex and perpendicular to the line containing on the opposite side. Opposite side. That means, now here is the triangle. Now I am drawing a line from vertex, from this vertex to the perpendicular to the opposite side. This line, starting from this line, this vertex, and perpendicular to this opposite side. This line is called altitude. Altitude. Altitude is a line segment drawn from a vertex and perpendicular to the opposite side. Perpendicular to the opposite side. This line is called altitude. Altitude. Altitude starts from a vertex and meet opposite side perpendicularly. Okay. Okay. Next. Now here is a triangle. Suppose this is the one altitude. This is the second altitude. And this is the, this is the third altitude. Now these 3 altitudes are meeting here at this point. Now this point is called orthocenter. Orthocenter, and it is represented with capital H. Capital H, that is written here. The point of intersection of 3 altitudes is called orthocenter. Orthocenter. Okay. Next. Now here is the acute angle triangle. Now I am drawing. This is one altitude. This is the second altitude, and this is the third altitude. This meeting point is called orthocenter. It is represented with capital H. Now this H is present inside the triangle only, no? So write down it in the statements. In acute angle triangle, orthocenter lies inside the triangle. Next, here is the right angle triangle is there. Suppose I draw a line from this vertex onto this line, but it is not making 90 degrees. Slowly I will come near to this line. Then when it is coincide with this line, then only it is making perpendicular line. So I am drawing like this. From this vertex I am starting the line and drawing like this, so that it is making perpendicular now here. If I start from this line, this vertex, and when I draw coinciding with this line, then only the altitude is making 90 degrees. Now this both altitudes are meeting at this right vertex. So this point is orthocenter H. Yes or no? Orthocenter H. Now in right angle triangle, in right angle triangle, orthocenter is at right vertex, right vertex, right vertex. Remember this point also. Okay. Okay. Next. Now this is obtuse angle triangle. Yes or no? If I draw from this vertex, I draw a altitude to this line, but it is not making 90 degrees. Altitude always make right angle, but it is not making right angle. So I extend this line. I extend this line up to here. Now if I draw like this, then it is making perpendicular with this line. Yes or no? Yes or no? Similarly, I extend this line. Just wait guys, for better understanding, I will make it in dotted lines. Just wait. This is extended line and this is per altitude. This is altitude. Now here also I will extend this line and I will draw the altitude like this. So here it is making 90 degrees. Now this both altitudes are meeting here. Now this is orthocenter H, but it is back side of this triangle, not inside the triangle or before the triangle or on the any side. There is no chance, but it is back side of the triangle. So write down this in the statements. In obtuse angle triangle, orthocenter lies backside of the triangle, backside of the triangle, backside of the triangle. Okay. Okay. Remember this point also, very very important point. This one also. Next. Now here is a triangle. Suppose this point is A, B and C, and this is the first altitude meeting at D, meeting on BC line at D, and this is the second altitude meeting AC line at E, and this is the third altitude meeting AB line at F, at F. Now we know the meeting point of three altitudes we call orthocenter, that is represented with capital H. This point is capital H. Now in triangle ABC, this triangle, this big triangle, in triangle ABC, the orthocenter is at H. Orthocenter is at H. In triangle ABC, the orthocenter at H point, at H point. Now in triangle BHC, the orthocenter at, I am talking about this triangle BHC, this triangle. This is obtuse angle triangle, no? So orthocenter lies back side of the triangle? Yes or no? In previous slide only I have said, when obtuse angle triangle is there, the orthocenter lies back side of the triangle. So back side, what angle is there? Vertex A is there. So this is the point where its orthocenter is present. So orthocenter for BHC triangle is, orthocenter is at A. A. Okay, remember this one. Now next, in triangle CHA, the orthocenter is at, talking about this triangle CHA, this triangle. Now this is also obtuse angle triangle, so its orthocenter is also lie back side of the triangle. At the back side, vertex B is there, so B is the point where its orthocenter is present. So its orthocenter is at B. B. Okay. Next, in triangle AHB, orthocenter is at, I am talking about this triangle AHB, this triangle. Now this is also obtuse angle triangle. Its orthocenter is also lie back side of the triangle. So at vertex A, its orthocenter will present. So at C, its orthocenter is at C. Remember these 4 points. Okay. Okay. Next. Now here is a triangle. Suppose this point is A, B and C. And suppose this BC length is small a and AC length is small b and AB length is small c, and this H1, this altitude length is, suppose H1, just wait guys, H1, this is the first altitude, and suppose this is the second altitude of length H2, and this is the third altitude of length H3. Okay. Now the relation between sides length and heights altitude lengths is H1 is to H2 is to H3 is equals to 1 by A is to 1 by B is to 1 by C. This is the relation between altitudes and sides, side length. Okay, this is also important condition. Okay, remember this one also. Next. Now here is the triangle. Suppose this point is orthocenter H. Now join this vertex and orthocenter. Suppose this angle, this opposite angle is theta, then this angle is equals to 180 minus theta. 180 minus theta. Okay. Remember this one also. Okay, that's all for today. Thank you.